Maybe you don't have a well on your property, but you have a spring. Developing a spring is a great asset, and using a solar pump, it's very simple to pump that water to where it's needed. This is Mike with RPS Solar Pumps, and today I'm going to go over a couple of different options for developing a spring and pumping with a solar pump. We'll talk about using a submersible pump, both with a float and by submerging it, and also a surface pump, so you can draw the water out of there and pump it to your desired location, whether that's pressurized or up to a storage tank. Here's a diagram of a popular spring installation. Springs usually need a collection area for the water to slowly seep out of the ground, and we suggest burying a tank next to the spring. The tank will collect the water at night, so you'll have a large storage of water in the morning to pump from. Our 3-inch and 2-inch diameter submersible pumps like the RPS 200, 400, 400N, 600, and 800, and even our Pro Series deep systems pump nice and slow, so you don't have to worry about pump cycling. Here we see the submersible pump laying on its side in the tank. Most springs we work with are low yield, meaning water is only flowing to the surface at a rate of 5 gallons per minute or less, and the flow rates might fluctuate seasonally. Lots of springs flow less in the summer and more in the winter. The low water sensor here guards against the pump turning on and running dry if there isn't enough water in the tank. It's a nice automated touch that doesn't require you, the property owner, to constantly be out here keeping an eye on the system. Here's our RPS controller, which holds the electrical brains of our system. A motor speed dial is in our controller, which allows you to easily adjust the pumping rate up and down depending on the amount of flow from the spring. There's also a timer delay controlled by a dial right below the speed dial. It shows from 0 to 30 minutes, which allows you to adjust the turn-off time when the low water sensor is activated. This gives time for the spring to refresh and for the pump to turn back on again. The timer delay works with the low water sensor, which is connected to the controller by a wire. The low water sensor is placed just above the pump, and if the water drops below the sensor, it's going to tell the controller to turn off and prevent the pump from running dry. Once the water raises back above the sensor, then the timer is going to turn on, and it's going to delay that long before the pump starts pumping again. In general, on a low producing spring, we'd set it at 30 minutes. That allows enough time for the water to come back above the sensor and allows for a longer pumping session. We'll talk about the second part of this diagram, pumping to a faraway tank, later in the video. Over here we can see one of our 3-inch submersible pumps. Now a lot of springs aren't very deep, and so it's okay to place these on their side within the spring in order to gather up your water, or you can also place it vertically. Here we have what's called a helical style pump. It does have a wear part, which we call the pumping mechanism here. Now if you have sandy or dirty water, this might not be the best option for you because this can wear out quickly in the case of a lot of sand pumping through it. Now don't worry, this is a field replaceable part with a lifetime warranty, so if it does ever wear out, it takes about 5 minutes to replace it in the pump. But we don't want you doing that all the time with really sandy or dirty water. So we tend to prefer this pump for nice clean drinking water. If you do have sand or silt in your spring, then we suggest one of our centrifugal pumps, the RPS 400V, the RPS 800V. You can also use the surface pump I'll show you later, or one of our Pro Series pumps. Those are much less susceptible to damage by sand and can handle some fine particulate or silt in the water without damaging. Plus, there's no wear parts, so there's nothing to wear out over time. In general, springs are prone to sediment issues, so we don't recommend laying the pump on its side in the bottom of your collection tank. If the pump is on its side at the bottom, any sediment that settles out is going to be drawn in by the pump, and it could possibly damage your pump, your pumping mechanism, or it's going to be pumped into your secondary tank, which isn't always great for that sediment buildup issue. That leaves a great option, which is floating your pump in your storage collection basin. In this case, we have two different options. We could do it vertically or we can do it horizontally, depending on the amount of water that you have available to draw off of. If you're going to mount vertically, we have a great float system that goes on the top of the pump that allows the pump to draw nice clean water and hang and adjust as the height of your collection tank goes up and down. Now we understand that requires a very deep collection tank, and so it's possible if you don't have that much room, you're going to need to do a horizontal mounting. We don't currently offer a horizontal mounting kit for your pump, but if you get creative with a little DIY energy, like I'm going to show you in a second, we'll go through how to mount it horizontally using a couple of floats, plus we're going to add some nice filters. If you get any big sediment or organic debris in your spring, it's going to help filter it out so it doesn't get pumped into secondary stages. Whether you're mounting your pump vertically or horizontally in your water source, I'm going to show you a great, easy to produce filter that's going to remove the large particulate and organic matter from getting inside of your pump and clogging whether you have a helical or a centrifugal style pump. Here is a 4-inch diameter pipe. You can use anywhere from 4, 5, or 6 inches. And it comes pre-drilled from the hardware store. We're going to add a couple of extra holes, and then using the materials you see here, we're going to create a simple DIY filter which is going to help extend the life of your pump. So we'll drill a couple of extra holes. So we have our extra holes drilled, and in this case I used a 5/16 inch drill bit, but anywhere around that size is going to work for you. Now that's still a little large for debris to come through, so we want to use some fine mesh to help filter anything else out. This is super easy to install and commonly available. We'll wrap it around our pipe, and then using a large hose clamp, we'll hold it in place. This provides a great secondary filtering of materials to prevent any of the larger pieces from coming through. Plus, it's super easy to apply. You can use a hose clamp, zip ties, wire, whatever you have available to make sure this is going to stay attached. Just a little bit of a word of warning, the edges here are pretty sharp, so you might want to wear some gloves when you're handling it to prevent a bunch of little nicks and cuts. So with a little bit of effort and a few cuts in our hands, we have the primary mesh covering all of our holes in our PVC pipe. Next, we're going to talk about how to cover the ends of our pipe and mount our pump. So on this side here, we're just going to use a simple 4-inch cap to cover the ends. It doesn't even need to be glued. There's not going to be much pressure or force on that cap pushing it loose. On this end, we're going to insert our pump, and you have two options to work with. One is you can use a PVC cap, drill some holes in it, and let your pipe slide through there. The other option is using a well seal, in this case a 4-inch well seal with our through fittings. We have our centrifugal pump here. Mounting is super simple. We're going to screw this in the end. Run our pump cable through the hole. And then this whole assembly is going to slide down into our PVC pipe, and we can tighten these screws in order to make sure it's all going to stay together. There we have our pump hanging down in our PVC filter. This is going to work both vertically if we're hanging it in a pond or in our spring, or it'll also work horizontally. If we're going to do horizontal, you might still have fine particles or sand going into your filter. In that case, that's where float comes in. So using either a couple of our floating balls, and in this case we just took a livestock float and added on an eyelet. This is a 3/8 inch eyelet that's screwed right in. Using a couple of these along the way, we can create a nice horizontal floating structure. You can also use a larger float like we use for our vertical setup like I showed you earlier. In that case, you're gonna have to use some rope, tie it off to either ends, and figure out a way to balance it to get it to float horizontally. Using some zip ties, or even better, some stainless steel wire, let's go ahead, attach these floats, and then we'll toss it over in our spring. So we've attached our floats. As you can see, we have our outlet up here. I don't have a thing attached right now. You can either attach poly pipe or a rigid pipe in order to transfer the water up and out of your spring. So let's head on over and show you how it's going to sit in our spring. So there you have it. We have our submersible 400V pump floating horizontal in our spring with an extra filter to strain out any larger pieces. Now in this case, I would probably add 1 or 2 more floats due to the depth of our spring here to help get it further from the bottom. You're going to need to adjust the amount of floats based on the weight of your system and based on the exact floats you have and how buoyant they are. But this will set you in the right direction in order to float your submersible pump in your pond horizontally with an excellent filter. So now let's talk about using a surface pump to pump out of our spring and how we would set that up. We'll head over to the other side, check out our surface pump setup using our T400 or our T800 surface pump. When a submersible pump is not quite the right fit for your cistern or your spring box, consider our surface pump. Here I have the T400 / the T800. The T400 uses 400 watts of solar panels and the T800 uses 800 watts of solar panels. It's the same pump, same controller, we just vary the amount of power depending on the amount of pumping head or volume you need. With the T800 and 800 watts of solar, you can achieve around 100 feet of pumping head at 7 to 10 gallons per minute. Now we have our complete setup here. And let's just pretend for a moment this is actually a 1,000-foot run off to our distant storage tank where we need to draw the spring water over to either a livestock tank, another tank, or maybe a household. Now you might not want to run a wire that whole distance. And so we have our reverse action pressure switch. I'm going to go over that setup in a second. And in the meantime, I'll talk about how we did our plumbing for our T400 surface pump. First of all, this is considered what's called a drip-proof pump. That means it can survive light rain, drips of water, not direct sprays or submersion. So it's always best to put a cover over the top. It's okay if you have a windstorm during the rain and water happens to get on it, but we do want to protect it in order to make sure it's going to last the maximum amount of time from the elements. Second, you're going to see our plumbing going out into our spring here. Out at the end of that, might be a little hard to see, we have what is called a foot valve. A foot valve is just like a check valve, but it has this filter on the end in order to filter out organic matter and large particulate. It also helps us maintain our prime. So the foot valve only allows water to enter, it doesn't allow it to drain back. So this is what's called a self-priming pump, but it does need some water in it in order to evacuate the air when it starts up. So if you don't have a foot valve and you have any leaks whatsoever in your pipes, then that water is going to drain back through and you're going to lose prime and possibly not run when you start up your pump. So the foot valve holds the water in here, and this is especially important in other pumps that are not self-priming. It's going to keep all of the water in there, and when the pump starts up, it's going to immediately start pumping instead of just churning air inside of the cylinder here. If you can't find a foot valve, you can make your own out of a check valve and adding some sort of screen material on the end. You can use a similar style as I showed you for our submersible pumps by putting a pipe, drilling some holes in it, and wrapping a fine mesh around it. If you have a lot of organic material in your spring, your pond, or anywhere else, you might need to do that anyways in order to increase the surface area to prevent clogging of this smaller filter here. The first time we set it up, we're going to install our foot valve out at the end and all of our plumbing. Before we make this vertical connection, which is the outlet of the pump, we're going to fill up that chamber with water as much as possible to get all of the air out. That's the first step before we add on the additional plumbing. And again, once we add on the additional plumbing, it's probably best to also fill this whole pipe with water. It's going to make setup so much easier when you start up the first time. It's going to evacuate all the air and make sure the pump starts right up. So as I mentioned earlier, this pump with 8 panels can pump around 100 vertical feet. That's what we call the pumping head. What that doesn't mean is the horizontal distance we can pump. So with horizontal pumping distance, we can increase the pipe diameter in order to account for the flow rates and the distance we're pumping and the frictional loss we're going to see. So that means with this same setup, we can pump thousands and thousands of feet to your remote storage tanks. So when you're pumping those kinds of distances, you're going to want to be able to shut the pump off when your remote storage tank is full. With that, we have three main options. The first one is we can run a wire that far for our tank full shutoff back to our controller. Now that's not the best option if you're running thousands and thousands of feet. It's going to drive up the cost of the wire, and it's going to be failure prone. If that wire breaks anywhere in between, you're going to lose connection, and then your pump's going to continue to pump and overfill your tanks. The second option, and one I highly recommend, is our wireless tank full system. You can check out in the description below a video we have of the wireless system. If you have line of sight in between your controller and your remote tank, it's a great option for shutting off your system. The third option is using a reverse action pressure switch to shut off when the tank is full. This is going to involve using a float valve in our tank that's going to raise up when the tank is full. The pump's not going to know that, and it's going to continue to pump water, increasing the pressure in our pipe. The reverse action pressure switch located near our pump is going to sense that pressure increase, and once it gets to a certain level, and we'll talk about adjusting the pressure switch in a second, it's going to close and it's going to tell our controller to turn off because we've reached the pressure and the pipe is full and the tank is full. Then later on, once some water drains out of the tank, the float is going to lower and we're going to relieve the pressure in the pipe. Again, the reverse action pressure switch is going to sense that, and it's going to open up and it's going to tell our controller that there's no longer pressure in the pipe. We need to start pumping again in order to refill our stock tank. Using pressure to tell our pump when to turn off is a super simple and reliable way of communicating tank status back to our pumping controller. I'll give you an overview now of how to set this all up. So let's go over the components and how we're going to set up our reverse action pressure switch in order to tell our pump when to turn off. So you might have heard me referencing a reverse action pressure switch. This actually operates in the opposite way of what's called a standard action pressure switch. So when a standard action pressure switch needs to activate the pump, it closes the contacts, allowing electricity to flow to the pump. When the pressure is reached, then those contacts open, cutting electricity to the pump. That would be for a standard AC style pump. In our case, with our solar pump controllers, we use what's called active open for operation. So that operates in the opposite manner, the reverse action. In this case, when the pressure is reached, the contacts close, sending a signal to the pump that the tank is full and we need to shut off. When the pressure drops, then those contacts open, and that again tells the controller the pressure is dropped in the system, we need to turn the pump back on to pump the pressure back up. So that's operating in a reverse manner. They're a little bit harder to find, but don't worry, we have plenty in stock, so if you need one, let us know and we can get one sent out right away. The next major component is our float valve. The ball here sits in the tank, and as the water level rises, it's going to cut off the flow of water. When the flow of water is completely cut off, then the pressure is going to rise in the system and the reverse action pressure switch is going to activate, telling the controller when to turn off. We also have a check valve here. So some of our pumps have a check valve built in and some of them do not. If you're doing this type of system, a check valve is required because when the pump shuts off, we need the pressure to stay in the system until the float ball goes down and the pressure is relieved in the tank, telling the pump to turn back on. So here we have our complete setup. This might look a little odd. We had to set it up this way for the video here. In this case, we want the pressure switch close to our pumping controller. That way we only have to run our wires into our tank full inputs a couple of feet. In between this pressure switch and our tank is where we're going to have the long run of pipe, thousands of feet if you need to go that far. We're just showing a couple of inches, but actually this switch is going to be located next to the pumping controller, and then from there we're going to have our long run of pipe. So we currently have our system set up with our T400. We have our 4 panels located off in the distance, our controllers mounted below them, and our signal wire is running over to our controller into our tank full inputs. On these pressure switches, we have a little lever here. This lever overrides the system and forces it to shut off even though it's not currently pressurized. This is great for setup. You can have everything set up and then flip the lever and then let the system operate. So I'm going to go ahead and do that now. We'll turn the lever down, and because there's no pressure in the system, you can see our contacts opened up. That just sent a signal over to our controller saying the tank is empty or there's no pressure in our line. We need you to turn on the pump and repressurize our tank. It's going to take a second. So there's two delays in this system. First, there's a tank full delay, and then there's a soft start of our motor over here. So you can see the motor is currently ramping up and increasing the water production. As this tank fills up, this arm is going to raise and start to cut off the flow of water. And as soon as we completely cut it off, we'll see the pressure builds up in our system and our pressure switch closes, telling the pump to turn off. So there we have it. With our float up, the pressure increased in our pipe, our reverse action switch activated, closed the contacts, sent a signal back to our controller to shut the system down. Now it's all going to wait here until our float goes back down, pressure is relieved, and then the controller is going to turn back on when the pressure switch tells it there's no more pressure in the system. So one more thing I wanted to mention. We do understand a lot of times springs are located down in the bottom of a canyon or gully where you might not have great solar exposure. Don't worry, as you see in this setup, I have the solar panels located back behind me, and we simply run our solar wire from the best solar exposure we have over to our controller. You can use various sizes of wires depending on your exact run. 12 gauge wire is generally good up to around 200 feet, and past that you're going to want to go with either 10 gauge or 8 gauge. If you're not sure on the exact solar wire selection, give us a call and we have it in stock. So if you need a lower gauge wire, don't worry, we can help with the extensions, we can pre-attach MC4 connectors to make everything plug and play. Let's talk quickly about elevation gains and some possible adjustments you might need to make to your pressure switch to dial in your system to make sure it reliably turns off when your tank is full. So if your storage tank is located on the same vertical plane as your pressure switch, you most likely don't have to make any adjustments. Now sometimes your storage tank will be located higher vertically than your pump. In that case, even though your tank isn't full, you're naturally going to have some pressure in the system due to gravity pulling down the water. Very similar to a gravity feed system. The formula to calculate that is 2.31 feet of elevation gain gives us 1 psi of pressure down at our pump. So we're 50 feet, we have around 22 psi down at our pressure switch, even though the tank isn't full. Right here, this is a 40-60 psi pressure switch. That means it turns on the pump when the pressure drops below 40 psi, and it turns off the pump when it rises above 60 psi. With 50 feet of elevation gain, we're probably still going to be good because we'll have the standing 20 psi of pressure, then additional of 20 psi of pressure that the pump's going to generate to turn it off. But if you're pumping, say, 100 feet up or even further using some of our pro systems, you're going to need to make fine adjustments to your pressure switch in order to get it dialed in so it reliably turns on and off when your storage tank is full or empty. A quick way to make this adjustment is being up at your tank with a walkie-talkie to a guy back down at your pressure switch to make the adjustments. You raise the float valve up manually, allow the pressure to stop flowing, and achieve full pressure in your system. If your reverse action pressure switch turns off, great, you don't have to make any adjustments. If it doesn't turn off, or in fact, when you lower the valve, if it doesn't turn on, you're going to need to adjust your 2 screws. Under the cover of your pressure switch talks about which screw to adjust and how that changes the turn on and turn off set points. I recommend making very small adjustments, maybe 1 or 2 turns of the screw, lowering your float valve manually, letting the pump turn on, and then raising it back up and cycling the system again to see if it reliably turns on and off. So if you have a spring located on your property, developing it and installing a tank or a cistern is a great way to add a reliable water source using a solar pump, and it adds long-term value to your property. This is Mike with RPS Solar Pump. If you need to install one of our solar pumps on your spring, give us a call at 888-637-4493. We can help walk you through all the options and get a great kit sent out right to your door. You can also visit us at rpssolarpumps.com.